Hello everyone, I'm SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we'll be discussing about computer organization and architecture.
So the secondary store, what are the types of secondary storage? So far we have discussed the cache memory, virtual memory. So the other type of the memory, it is known as a secondary type of storage. So the semiconductor memories do not provide all the storage capability. So the secondary storage provide a larger storage requirement. Some of the secondary storage devices are magnetic disk, optical disk, and the magnetic tapes. So for your syllabus, only the magnetic disk is been given. Okay, let us discuss on what is a magnetic disk. So magnetic disk system consisting of one or more disks mounted on a common spindle. A thin magnetic film is deposited on each disk. The disk is placed in the rotatory drive so that magnetized surfaces move in close proximity to read or write heads. So each read or write head consisting of magnetic yoke and magnetizing coil. So the digital information is stored on magnetic film by applying the current pulse to the magnetizing coil. So the only changes in the magnetic field under the head can be sensed during the read operation. Therefore, if the binary states 0 and 1 are represented by two opposite sides, then the voltage is induced in the read in the head only at 0 to 1 at 1 to 0 transition in the bit stream. So the consecutive zeros and ones are determined by using the clock. So the Manchester encoding is used to combine the clocking information with the data. So this is what hard disk memory which is been placed inside the CPU. So these are the disk depending on the capacity, I mean the storage capability or storage needed. So the disk are going to be implemented. Each disk is going to have the two read or write header. So so this is what the disk here, the four disks are there. So eight read or write header is going to be placed on the disk so that it is going to read up or the bottom of the disk storage. So this is what it is. This what the read or write header, which is been writing the data on the disk or read from the data from the disk. So this is what been connected. This is what read or write head. This is what read or write head, and this is the motor of the actuator arm. This is the motor of the actuator arm, and this is what actuator arm, and this is the spindle where disk is connected, and this is going to rotate. So the small millimeter distance be maintained from the disk to the read or write header. So this is how the writing process by the processor head. So it is going to it is going to send the current pulses to write on the disk. So this arrow is indicating downward arrow, that is a magnetic pulse generated by the coil. So downward arrow, it is nothing but it is writing the 0, and upward arrow is nothing but it is going to, depending on the current direction. So if it is for upward direction, north pole, then the current facing up, the current logically 1 and 0 representation. Gray block is nothing but the no bit. So this is what read head, and this is what the write head. So the north pole direction 1 bit, current direction bit 1 is written. The same north pole arrow is facing down, is nothing but, I mean when the flow of current is in opposite direction, then if it is facing towards the down, then it is going to write the bit 0. So this is what the read operation. Read head will take logical 1 and 0 representation. So north pole facing up, it is going to take the bit 1, and the north pole facing down, it is going to read the bit 0. So this is what it is going to write the bits on the disk serially. It is going to write the disk not parallel. It is going to, because one read or write head for each disk. So it is going to write the data on serially and read it read data sector wise, in group wise. So this is what the you can see, that is the whenever it is reading sorry, writing the bit 0, so you can see the direction of the current, it is move facing down. The movement of the current is going to be facing down. So here you can see whenever it is reading 1 or writing 1, so the movement of the current is going to be upward. The movement of the current it is upward. So this is what in the textbook diagram given regarding the hard disk, magnetic disk. So this is what the spindle, and this is the number of disks connected, and this is what the read or write head being connected to the arm, actuator arm, and this is what the head of the read or write header is containing. What is that? Magnetizing current is starts flow. So this is what the magnetic yoke, and the air gap between the magnetizing sensor and the disc. So this is what the magnetic thin film which is placed on the disc. So this is how it is going to read the pulses. Low to high it is bit 0, high to low it is bit 1. So for both the read and the write operation. So read or write heads are maintained at a small distance from the disk surface in order to achieve the high bit densities. When the disk is moving at the steady state, the air pressure developed between the disk surfaces and the head. So this air pressure forces the head away from the surface. So the flexible spring connection between the head and this arm mounting permits the head to fly at the desired distance away from the surface. So the Winchester technology, that is read or write heads, are placed in a sealed and air filtered enclosed closer to the Winchester technology. So the read or write head can operate closer to the magnetic track surface because the dust particles which are a problem in unsealed assemblies are absent. So that what is the advantage considering this Winchester technology? It has a larger capacity for a given physical size. The data intensity is high because the storage medium is not exposed to contaminating elements. So the read or write heads of a disk are movable. Disk system has three parts. One is the disk platter, disk drive, and the last one is the disk controller. So this is what the platter, the structure of the hard disk drive, that is a secondary memory. The platter is a circular magnetic plate that is used for storing the data in a hard disk, and it is often made of aluminum, glass substrate or ceramic. So the hard disk drive contains the several platters. So each platter has two working surfaces. These surfaces of the platters hold the recorded data. So the next is the typical that is the hard disk drive design consisting of a spindle. So this is what the spindle, which is the motor that holds the platter. This is what the and also supports this to move. So each working surface of the platter is divided into number of concentric rings. So that are called the tracks. So the collection of all tracks that are same distance from the edge of the platter, it is called the cylinder. So this is what the first track, it is the distance is going to be, the same distance is going to be maintained for all the discs. So that is going to form the cylinder one. So another track of 2 which is of same size in all the discs will form the cylinder 2. So the data is on a hard drive. Platter is read by the read or write heads. So the read or write arm, the read or write arm is also known as the actuators. So this is what the read or write arrow is going to be placed. So this is what read or arrowhead is going to be placed in yellow color. What it is indicating. So the organization and accessing of a data on it is each surface is divided into concentric tracks. Each track is again divided into sectors, and the set of corresponding tracks on all surfaces of the stack of a disk from the logical cylinder, which is going to form the logical cylinder. So the data are accessed by specifying the surface and the number and the sector number. And the read or write operations start at the sector boundaries. Data bytes are stored serially on each track. So structure of the secondary memory, the tracks is each platter is broken into 1,000 tightly packed concentric circles known as tracks, and these tracks are resemble the structure of annual rings of a tree. All the information stored on the hard disk is recorded in the tracks, starting from 0 at the outer side of the platter, and the number of tracks goes on increasing to the inner side, and each track can hold a large amount of data counting through thousands of bytes. So sectors is nothing but each track is further broken down into smaller units called sectors. As sector is a basic unit of storage on hard disk, which track has the same number of sectors, which means that the sectors are packed in much closer to the tracks and near to the center of disk. A single track is typically can have thousands of sectors. Data size of a sector is always the power of 2, and this is almost either the 512 or the 409. As a sector is a basic unit of the data storage which can store a power of 2, that is almost always either the 512 or the 4096 bytes. So the clusters, the sectors are often grouped together to form the cluster. So the cluster is the smallest possible unit of storage on a hard disk. If the contiguous clusters, that is a cluster that are not next to each other on the disk, are not available and the data are written elsewhere on the disk, so the file is considered to be fragmented. So, time required the read or write head to assemble or to move or to reach or to find the desired track or the cylinder, that is move from one track or the cylinder to the another. It is known as the seek time. So this is what the structure of cylinder 1, and this is the structure of cylinder 2 you are able to see. So when the content should be read from the track 1 and the platter 1. So it is going to be select the disk 1 and the platter 1 by the read head, and all other read or head are going to be inactive. So that is what here the content to be read from the track 2 and the platter 1. So the moving and it is the first header read header is going to be activated, that is track 2 and the platter 1, and the other being going to be deactivated. Other read or header, write header, which is going to be placed on the magnetic disk are going to be deactivated. So this is the example for track 2 and the platter 3. So this is what track 2 and the platter 3 is nothing but this is going to be the platter and this is going to be activated, and another two read or write header is going to be deactivated. Okay, so this is what. So in the sector 1, being initially the header read or write header is in the sector 1. The data has to be read from the sector 5. So then it has to move to the sector 5. So here going to be the movement of the sector 5. So the time taken, that is total access time, that is the seek time is to set the track, and plus rotational latency. Time taken by the read or write assembler to reach the desired sector is the rotational latency, and the seek time is the time taken by the read or write assembler to reach the desired track. So track, and in that track particular sector should be selected. So that is known as the access time. So the what is the transmission time? So both the access time plus the read time taken by the processor or the memory management unit, or the, so that is known as the total transmission time. So in detail, so the each sector is usually contains 512 bytes. Sector header contains the identification information. It helps to find the desired sector on the selected track. So what is ECC stands for? ECC stands for error checking code. Is used to detect and correct the errors. So unformatted disk has no information on its tracks. So the formatting process divides the disk physically into tracks and the sectors. So the formatting process may discover some defective sectors on all tracks. So the disk controller keeps a record of various defects. So the disk is divided into logical partitions. One is known as a primary partition and the other one is known as a secondary partition. Each track has the same number of tracks, so sectors, so that all tracks have the same storage capacity. Thus the storage information is packed more densely on inner track than on outer track. So what is access time? There are two components involved in the time delay. Seek time. Seek time is equal to time required to move the read or write head to the proper track. So the latency is the latency or rotational delay. The amount of time that elapses after read is positioned over the correct track until the starting position. The addressed sector passes under read or write head, and the seek time plus latency time is equal to the total access time.